Okay, this learning goal is you can convert from decimal notation to standard notation and vice versa. So number 1 and number 2, they give us decimal notation and we want to rewrite it in standard notation. Hey, can you shut the door for me, please? Thank you. Okay, so 6 hours. So the whole number 6 comes into this place. And each one of these problems is worth 4 points on tomorrow's test. I take whatever is past the decimal, so 0.295, and I ask myself, how many minutes are there in an hour? I always go backwards to the left. There are 60 minutes an hour. The whole number 17 goes in this place, taking the decimal and asking how many seconds are in a minute, times 60 for 42. Doing one more like this. So hours and hours, we take the whole number, it goes into the first place. Now the decimal point, I'll move it to the side so you can see it, 0.675. That's this portion right here. How many minutes are there in an hour? 60. So taking that times 60, keeping the whole number, and then what's past the decimal. So this partial minute, asking yourself, how many seconds are there in a minute? 60 again, 4:30. Okay, going on to the next part. Now I'm going to go back into decimal notation. So this numerical value I write can only be in terms of miles. So I know there's 3 miles. And what you have to know is there's 5,280 feet in 1 mile. That is on the board. So I'm going to write all of this in terms of feet. 4820 plus we have this additional. And so on today's application test, I saw some people on part 18 that they knew they had to do this. I think it was 618 was the problem. They knew they had to break this apart, but they didn't know what number goes down here. So look up above. How many inches are there in a foot? There are 12. So I'm going to take my calculator and I'm typing in 4820 plus anything in parentheses. Sorry, any fraction will go in parentheses. Now this represents the amount of feet. Again, I need to write this all in terms of miles. So I'm going to take this and divide this by 5,280, and this answer now goes over here. So 9129, so it says round to the nearest thousandths. That means I go to the third place and I look behind, it says to round up, so 3.913. This would be my answer for number 3. Same concept here. We're going to go into decimal notation. So 2 miles, that's the whole number. And then I'm going to rewrite this in terms of only feet. 3760 plus, asking myself, how many inches are there in a foot? There is 12. This is the part of confusion for some students, that denominator value. Okay, so this is feet. And again, I need to write it all in terms of miles. So I take this measurement in feet and I divide it by 5,280 and writing this down. Okay, and now I go back around to the nearest thousandths. That's 3 places over. And I look behind and it's not 5 or greater, so 2.712. Out of these 4 problems, you'll have one like this worth 4 points and one like this worth 4 points. Going on to number 5. We're going to sketch the function and it tells me exactly what the window should be. So when I start, I'm always going to go for every problem. I'm going to go back to clearing the window. So I'm going to go to y equals, I'm going to plug in the function that's provided to me. If you see me as I'm trying to go through this quickly for you, if you see me make a mistake, just let me know. So I plug it in, but now for this problem, it says, hey, I'm going to tell you what I want the window to be. This tells you the minimum x and the maximum x. Notice it's the smallest x and the largest. So I'm going to change it, and then I'm going to go to the y's and do the same. This is the smallest y and the largest y. So -10 to +20. Okay, now I'm going to graph it. And now based just on this window, it wants me to draw the picture. Okay, so notice it comes over this part and goes up. It goes something like this. And now it says, what is the y-intercept? The first time you hit trace, and remember for y-intercepts, I already mixed up. For y-intercepts, the opposite variable, the x variable, will always be 0. Notice that when I hit trace that time, that x is not 0. So I need to figure out what is the y-intercept. Second traced value. I know when x is 0, I will always have my y-intercept. In this case, it is 0, 1. Generally, you can just hit trace one time and you'll know exactly what the y-intercept is. Going down to the next one. Again, every time I do a new problem, I always do second plus 712 to clear this. And I'll put those instructions, second plus 712, as a reminder of how to clear it. So I'm going to start by plugging in the formula here. The function I have looks quadratic, so that will provide me with an idea of what the shape will be. It'll be some type of a U shape. Now it says complete this, and then we want to round. So they give us an input value, and we want to know an output value. So when we graph this, we see a picture. We don't have to draw the picture. And now here's the problem. A lot of you got stumped with this when you were trying to do this last Thursday and Friday. You went second trace value. Again, I'm going to slow that down for anybody who's stuck. You're going to go second, and then see how when you hit blue, it goes to calculate. So second, hit the button trace, and then I want to go to value. And when you plug in 16.1, it gives you a message that says error. Like, how do you find this? This is the reason why. It's not that it doesn't exist. It means under the windows that you're looking at, notice that your X's only go between -10 to +10. So if we want to think about your integers, obviously we know there's numbers in between, but here's -10, here's +10 and 0. Right now, my X is the window I'm looking at only goes between here. Every decimal, every fraction, every integer in between here. I want to go to 16. 16's way over here, but I haven't adjusted my windows to see that. So if you ever get that invalid message, again, it looks like this. I plug in -16.1 and you see an invalid message. It means you need to adjust the window so that you can see that point. So we're going to do that right now. Well, how do you know what to adjust to? I just know I have to go past 16.4. So in my mind, well, what's the next whole number after 16.4? 17. And now I'm not going to do all of these because it's a waste of your time, but I can go second trace value. I type in 16.1, and then it says round to the nearest tenth. So if I zoom in this for you, I'm going to round to the nearest tenth. That's the first place after the decimal. So 332.7. I don't round up. 332.7. Let's do one more. Second trace value, 16.2. Again, I'm going to round to the nearest tenth. 336.4. 336.4. And you guys could take care of these last two. So same thing, you do second trace value, typing in 16.3 and 16.4 to get those values. All right, so if you're just coming in with me, it's always better to be late than not at all. We just finished our first page. We've done 6 problems. I would like you to go back and to watch that video for those first 6. Okay, second trace, second plus 712. I'm clearing the calculator. Now you're going to find this on the board in order to get to this symbol. And actually, you know what? I want to rewrite that. I know that it was an absolute and I changed it to a radical symbol. I know this is what it should have been. Okay, so y equals 2 plus the absolute value of x minus 2. How do you find this absolute value? And I'm going to show you how to do that. You're going to hit the math key. Then you're going to scroll across the top to what appears like number, NUM. And the very first thing says ABS for absolute value. So I've cleared my calculator. I go up to y equals, and I start to type this in, 2 plus. Now, how do I make this absolute value? Find math. Now at the top, use this arrow to go to number. And it's the very first thing. You press enter. And I just type in what I see, x minus 4. Now it says use the graphing calculator to sketch in standard viewing. Whenever you see standard viewing, it means after you cleared your calculator, this is what it automatically diverts back to. Okay, this is what it reprograms itself to. And this is called your standard window. So I want to graph exactly what I see. Okay, so it looks something like this. And then it says, what is the y-intercept? So when I hit trace, I should see it. This time it works, 0, 6. How do you know if you found the right y-intercept? Well, there's only one y-intercept for every single function, and your x value will always be 0. So if it, for instance, would have somehow given me something like this when I hit trace, and it was not x equals 0, then I just do second trace value. I type in 0, and there it goes. That's my y-intercept. Going down to number 8. Now, number 8, previously I tutored about finding maximums and minimums. I'm going to do just a quick little preview of that with 4 graphs. This won't take more than 2 minutes to do this. So I'm just going to make up 4 different functions. Just going to draw a little picture of 4 different functions. Okay, here's the first one. Second. Third. Here's the fourth. Okay, so there's something that's called, and instead of me telling you both terms, it's called relative Another teacher, if you got tutoring, maybe call it local. It means the same thing. And we say there's relative minimums, and we say there's relative maximums, and that refers to a low point and a high point. It just can't be the lowest or the highest. So if it's the lowest or the highest, we call it absolute, because there's absolutely no other point that ties it or is greater. So we have absolute minimum and we have absolute maximum. And again, if you got tutoring from somebody else or you Googled this, they may refer to absolute as global. We'll talk more about that when we get closer to that test at the end of year. But again, minimum is a low point and this is the high point. Okay, so I'm gonna start over here, and all I'm gonna do is I'm just going to identify, like I'm going from left to right, and I'm taking my son's little toy cars, and he's just gonna follow along. This is a pathway like you're driving. And whenever I get to the top of the hill, I'm gonna make a dot. Whenever I get to the bottom of a valley, I'm gonna make a dot. So I'm just starting right here. I'm doing that exact same thing. So here I go. I'm driving, oh, top of the hill, bottom of the valley, top of the hill, bottom of the valley. Okay, simple enough. Now, why did I not make a dot here or a dot here? Because in order for me to make a dot, it means it's the top of a hill, but this isn't the top, it's continuing to go. This arrow means it's never stopping going up and it's never stopping going down. Let's make sure that you are muted right now if you just joined me. Thank you. Make sure you're muted. Awesome. So on this particular problem, we say that there is no, please make sure you're muted. We say there's no absolute minimum and there's no absolute maximum. And that's sometimes hard for students to understand. Sometimes it takes a couple times. We're going to learn more about that in September. Why isn't there a high? An absolute means there's one and only one point that's the highest. And the reason there's not, because the arrow says it keeps going up and it never stops. So I can't pinpoint one. I can't say this is the highest or this is the highest because this isn't the highest. It keeps going. I can't say this is highest because it keeps going up and it never stops. So I can't identify the highest or the lowest. So this graph does not have an absolute minimum. It doesn't have an absolute maximum, but it does have relatives. So relative minimums and relative maximums means there's still high points and low points. They're just not the highest or the lowest. So this is an absolute a relative max, a relative min, a relative max, a relative min. Going over here. This particular graph does not have an absolute maximum for the same reason. It has arrows going up that never stop, so I can't pinpoint one and only one point that's highest. You'd say, some people would say, well, this one's higher than this one. No, because this one means it just keeps going up and never stops. That's what the arrow means. So this has no absolute maximum. It does have an absolute minimum. This is the lowest point. There's no other point in this graph that's as low as this point. Now let's talk about relative maximum and minimums. Okay, so here's still a high point, it's just not the highest. Relative maximum, relative minimum, relative maximum, relative minimum. And we're going to figure out what are those points in just a second on the next problem. Okay, here, again, this does not have an absolute maximum because it keeps going up, so we can't pinpoint one and only one point that's highest. And it does not have an absolute minimum for the same reason. It never stops going down as it moves to the right. Now, we do have low points and high points, but they're just not the lowest and the highest. So this is a relative minimum and a relative maximum. Over here, same reason here. We don't have a high point that stands out from all other points. So there's no absolute maximum, but we do have a low point. So this would be an absolute minimum. And you may be saying, well, what about like the relative? Well, over here, there's not as many turns. So those turning points we'll talk about later on, but there's not as many turns to have still high and low points, just not the highest. So this only has an absolute minimum. Okay, all of that, let's come back here now. And it says to graph this, wrong page there. We're going to graph this, so 2nd plus 712, and plugging this in. Okay, great. So I have x to the 3rd plus 3x squared. Oh, shoot. Let's go back. Just pulled a common mistake by students by not looking at my screen as I went through it. Let's make sure it looks the same. Okay, now I graph it. Okay, awesome. So again, even though there's not an arrow here, it's insinuated there's an arrow. So it's never going to stop going up and it's never going to stop going down. So I know that absolute maximums and absolute minimums, they don't exist because there's not one and only one point that stands out at the highest. This would be referred to as a relative max and a relative min. Minimum being the lowest of the two, and this being maximum being higher of the two. So I'm going to be lazy here. We have relative max and relative min. Now, how do we get those exact precise points? We're going to round to the nearest tenth when we do it. Okay, second trace, go to maximum. I'll slow that down for anybody right now. Second trace, and now we find the function right there, maximum and minimum. I'm going to go to maximum first, and I'm going to use this little arrow to go up to the very top of the hill. Now a little bit to the left, a little bit to the right, and back on it. Okay, rounding this to the nearest tenth. If I move this off to the side, this puts me at negative 2.4 and 4.6 when I round to the nearest tenth. Now I'm going to do the relative minimum. Now I know that in the last 15 years, this is a concept that some students take a couple weeks to get. Can you be completely honest? I appreciate that. Don't be embarrassed if you're somebody who's not understanding. Can you give me a 1 through 5 on this particular concept of identifying relative maximums and minimums and understanding that there is not an absolute maximum and an absolute minimum? Give me a 1 through 5 on your understanding of that while I get ready to go on to number 9. So go into the chat, please, and give me that feedback. Okay, so whenever I plug this in, what I often saw students do wrong on the review last Thursday is they did not use parentheses. Whenever you have a fraction, you're going to plug in with parentheses around the numerator. I sometimes tell students, think that you're hugging the numerator with the parentheses. So I'm doing that divided by x plus 1. Thank you for letting people in. Make sure to let them into tutoring, please. So I have the numerator and the denominator, and then I hit trace, and it says in this window, just sketch what you see. Okay, so I'm sketching what I see. I see something like this, and I see something like this. Now, remember from last week, we talked about the denominator. You can have whatever value you want on top, but the bottom can never equal 0 once you plug in a number for x. So you're like, well, I don't see a 0 here. Well, when you substitute in a number for x and you do the math, you never can have it equaling 0. So I'm going to come off to the side. Some of you will just do this in your head. I'm going to set it equal to 0. And then I get, okay. So if x equals -1, I'm in trouble because -1 plus 1 is 0. Okay, I don't want x to equal -1. And that's why you have this portion where no output value ever goes along the vertical line, x equals -1. Now, how do I answer these? Okay, so once I have this, I go second, trace, and go to value, and I just type in -1. Oh, see, when there's no answer, don't put none. We use the word undefined. And now if you don't want to write the entire word out, you can put UND. Or put none, but just don't put 0, okay? But this is really the math term, undefined. Okay, now second trace value, typing in 0. So this is my 0. What's the output? The output is -3. Second trace 0, typing in 1, and the output is -1. Going on to number 10. Using a graphing calculator, we're going to calculate the zeros, and round to the nearest hundredth. Every time I start a new problem, I do second plus 7, 1, 2. All right, plugging this in, 3x squared minus 6x minus 7. Okay, wonderful. So I graph it. And now I want to find these exact zeros. Here's what not to do. Okay, I'm going to hit trace. And some of you have learned this bad habit in like a freshman class. It's right about, I'm going to call it -0.8. We want the exact precise point. So I can see there's 2 x-intercepts. Remember, another word for this may be roots or x-intercepts. So how am I going to find that? I know I have 2 answers, and I want to round to the nearest hundredth. That's 2 places past the decimal. Okay, I'm going second trace, and I'm finding the word 0. And then I want to just choose any integer that's to the left, so like -3. And you're going to see this temporary vertical line. And then I choose any number that's to the right, but it can't be all the way to this other 0. So I'm going to choose like 1. Perfect. Now the vertical temporary lines are to the left and right of my 0. I press enter, and here's the answer. Rounding to the nearest hundredth, this would be negative. Let's see if you're on your phone. We'll zoom in here. Negative 0.83. And then I'll do the next point. Second trace, go to 0. I choose any point to the left, so I'll choose 1. Any point to the right, I'll choose 5. Okay, we got the lines to either side. I press enter, and we have an answer of 2.8 rounded to the nearest tenth. Am I supposed to do tenth? Hundredth, yes. 2.83. And by the way, this is the same as 0. This is scientific notation that pretty much is 0. Thank you for your continuous feedback. I want you to go into the chat, and I'm okay with you having a thumbs down if that's where you are now. I want you, if you feel pretty good about what we've gone over, to give me a thumbs up. If you're like, I'm just not ready, give me a thumbs down, please. Okay, we've already done a problem like this, but I know a lot of times that students struggle. Remember to always put parentheses when you plug it in. I clear the calculator, I come back, I have 2x minus 3. Whoa. That's what happens when you rush. Divided by x plus 2. So thank you for letting people in as they enter. So I have the function and I hit graph. And remember, I have to ask myself, and some of you can just do mental math, what can x not be? Okay, so I set the denominator equal to 0 and I get -2. I never want x to equal -2 because if I substitute -2, I get 0. So I already see -2. I already know this is undefined, which you can abbreviate if you want. Okay, what do I do once I have this? Well, let's graph what we have. So we know at -2, we can't have an answer, and I'm just going to draw what we have here. Wonderful, very simple sketch. And now second trace, going to the value, and let's see, what is the output when the input is -1? Second trace value, if I get a -1, I get -5. And you can see when I type in -2, it's blank. So this blank answer means that there is no, this doesn't connect to any output value. So that's why we write undefined. Second trace, type in a -3, and we have an answer of 9. Okay, using a graphing calculator, let's find those zeros again and round to the nearest tenth. Always start by clearing your calculator, going up to y equals, I have x squared minus 8x minus 11. I'm going to graph it. These are the answers I want. Remember this, I went from -10 to 10 because it always puts me back into that standard window. So I'm keeping that in mind. Okay, so to the left and right, here we go. Second trace value. So somewhere to the left, -5. Somewhere to the right, one, maybe I hit the wrong thing. Let's try this again. -5 and 1. So anywhere to the left and right. And now I want to round to the nearest tenth this time. So -1.2. -1.2 and 0. And now this next one, this is a little bit trickier. Okay, so somewhere to the left is easy, like 5. But I know this is 10. I'm going to do 10. So there's 5, there's 10. Press enter, 9.2 and 0. Okay, number 13 and number 14, you had a problem like this on 18a today, where we are going to come up with an equation y equals mx plus b that contains both of these points. So we always start by doing y2 minus 1 over x2 minus x1. And I always suggest you put in your parentheses. Remember, y's first, and the order you plug them in doesn't matter. So this is the first point, and this is the second point. All right, here we go. Y2 is -1, y1 is -11, x2 is 2, x1 is -3. Now, what if you're not as comfortable with integer operations? Well, then grab that calculator. I need to see your work. So if you got the right answer, but you had no work, then I considered it like cheating today. So this is work. Now, at this point, if you're still not real comfortable with integer operations, -1 subtract -11. I write down the number 10. Okay. 2 subtract -3. I write down the number 5. Again, if I'm not comfortable, 10 divided by 5. Okay, and you can still get the right answer. This is our m. It represents our slope between these 2 points, the rate of change between these 2 points. I need to have an m and a b. So how do we come up with the b? Y equals mx plus b. Choose either one of these points. There's no wrong answer. 2 will be the x value. -1 will be the y, and then I'm just going to solve for b. So 2 times 2 is 4. And then to isolate the b, I need to move the 4 to the opposite side. Opposite of adding 4 is subtracting 4, and I get b equals a -5. -4, -1 is -5. What do I do with these two answers? Here's my final. Y equals 2x minus 5. All right, here's the next one. X1, Y1, X2, Y2. Again, we are going to plug this in here. And we're always going to do the Y2 first. So 1 subtract 5 and 4 subtract -4. 1 subtract 5. Again, and if you're not comfortable, you do 1 subtract 5, and you write down the answer. And if you're not comfortable, you do 4 subtract -4. And then you divide, so not to get -2, to get -1/2. What if you don't reduce it? You'll still get the right answer in the very end. Y equals -1/2 x plus b. Choose either one of these. I'm going to choose this one. It has no negatives, but you could use the first one. Here's my x and my y. Half of 4, I'll zoom this out so you can see. Half of 4 is 2, and there's a negative sign. Now, how do you isolate the b? We need to move it to the opposite side. Opposite of subtracting 2 is adding 2. 1 plus 2 is 3. So there's my m, and here's my b. Y equals -1/2 x plus 3. Moving on to the next page. Thank you for remaining with me. If you came in late, always better to arrive late than not at all. Go back and watch this video when it's posted. This part. I spent about an hour and a half creating this today, so thank you for being with me, and hopefully it helps. Okay, moving on to the next part. We want to know, where do these 2 points intersect, and we want to round that intersection to the nearest hundredth. Always start by clearing your calculator. I'm going to go up to y equals and type in x squared, subtract 4x, subtract 5. The next one, negative. Now, when you have parentheses, when you have fractions, put them in parentheses. So -1/2 x plus 3. I'm graphing it. Let's see, how many times does it cross? Oh, it crosses twice. Awesome. So I'm going to have 2 points where it crosses. And we want to round this to the nearest hundredth. That's 2 places past the decimal. So how do we figure these out? What not to do is this. I'd say it's right about there. We want the precise point where they cross. Second, trace, and we're going to find this app or function intersect. And now, once you're close, you're going to hit enter, enter, enter. It'll say intersection point. So -5, -1.58 and 3.79. Should have this there. And now let's find the second one. And we're probably going to have to move our cursor a little bit closer to where it is. But second, trace, intersect again. Again, you're going to move a little bit closer to where your next intersection point is before you just hit enter. When you have more than one intersection, enter, 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 and here we go. 5.08 rounding to the nearest hundredth, and 0.46. I'm going to clear my calculator and going on to number 16. We are getting close, kiddos. We are within 5 problems of being done. Okay, using the graphing calculator, sketch the following in standard window. Remember that? All that means is clear the calculator, plug it in, and sketch exactly what you see. That's all that means. Now, this is a little bit tricky to plug in. So 2 is the base, simple enough. And then I use a caret key, which is right here. This is the caret key in order to go up to an exponent. Typing in 2x, and notice that the 6 is at the same level of the 2. So I need to use the arrow to go back down. Okay, great. And now subtract 6. What you don't want is this, 2 raised to the 2x minus 6. Notice how the subtract 6 is not at the same level as a 2. It's still in the x1 position. That's a common mistake I see. Once you have this, you're going to graph it. You're literally going to sketch exactly what you see. Okay, I'm looking. Okay, something like this. Done. Now it says, what is the y-intercept up here? So when I hit trace the very first time, we can see the y-intercept is 0, -5. So y-intercept is 0, -5. Okay, we're going to do just the relative maximum here, just the relative maximum. In fact, this may be, I made this up, and this may actually be the absolute maximum. Well, let's check. Okay, so it's weird. We cleared this. Oh my goodness. There we go, cleared it. And I have a fraction, so it's going to go in parentheses, and x squared, and I have another fraction that's going to go in parentheses. So I'm trying to rush here because I didn't know it's really late at night and you're tired. Okay, we graph it, and we want to know, what is it? And actually, this is an absolute maximum, so I should change that for next year. But we want to know, what is this exact point? Again, what not to do is just hit trace and be like, I think it's like right there. How do we get the precise point? Second, trace. We're told it's a maximum. We can see that. We go a little bit to the left, go a little bit to the right, and back on center. All right, so we're going to write this down, and we're supposed to round to the nearest hundredth. So 0.0 4.37 and 4.09. Using a graphing calculator, find the intersection points. So second plus 712. 4 problems left, kiddos. X subtract 5. X to the, 3 to the X, bring it back down, -8. Okay, I've got them. Let's graph this. 2 intersection points. So second trace, find that intersection. I'm going to get close to one of them, and then I'm going to press enter 3 times. Enter, enter, enter. Rounding to the nearest hundredth will be -2.96, and output of -7.96. Now I'm going to move second trace, intersect. I need to move this closer to the second intersection point before I press enter 3 times. And the second one is going to be 1.34 rounded and -3.66. The 2 places in which they intersect. Using a graphing calculator, we're going to sketch this. Sorry. Nice. And we're going to identify the zeros. Okay, simple enough. I go up to y equals 3, subtract. I have a fraction, so I put it in parentheses. And I'm just going to sketch what I see. So here's my graph. I'm going to sketch exactly what I see. It's something like this. Simple enough. Now it says to identify the zeros. There's only 1 0. How do I identify the 0? Hold tight, I know it's like kiddos. Second trace, go to 0. I choose anywhere to the left here, like give me any one of those numbers. I'm going to do 2. And anywhere to the right, like maybe 5. Okay, and the 0 is in between. I press enter, and the 0 is 4 0. On our last page, there should be just a few problems remaining. That we have not tried tonight. Second plus 712. I will write the instructions to number 20 on the board. So I'm giving you data points. Hopefully I chose these right, because it was by this point the kids were hungry and I'm trying to make dinner. So anyways, hopefully I chose this correctly. So I have data points. I'm told I'm going to use a linear regression model in order to come up with an equation. So my final answer will look something like this. Okay, so what do we do first? First we hit stat and we go to edit. Again, the directions will be on the board. How do you create a regression model, but you have to know when to follow them. So I hit stat first and I plug in what I have: -5, -1, 4, and 7, and then -20, -8, 5, and 16. I do want to remind you, pressing enter each time, the negative key is below the 3. That is different than subtraction. What do we do next? We're going to go to stat and we're going to look to calculate. It's going to give us the actual equation that best fits these points. And we want to go to linear regression. How do you know to go there? Because it says linear regression, and this is the abbreviation for linear regression. So I go there, I press enter all the way through, and this is what I have. So what do I do with that information? It should say like round to the nearest something or other. I want to make sure I didn't make a mistake there. I easily could have. That looks right. This is just an example of that when I was cooking dinner and the kids were, I wanted to be prettier than this. So it would say round to the nearest 10th or so. I'll tell you that the problem you're going to work with, it provides you nice integer answers. But here we go. 2.9x, if I round it to the nearest 10th, subtract 5.4. So then you write that in. Again, I'm telling you that you will have nice integer answers for A and B, so you're not going to have to round. And again, on your test, it tells you what to round to each time. Very last problem. If you're with me and you haven't fallen asleep, you deserve a star. Here we go. I'm going to type this in. I cleared the calculator, and I'm very apt to make small mistakes right now, trying to rush through this. Okay, I've done that. Now here's the deal. It tells me exactly what to change the window to. So I go -20, oh, sorry, -20 to 10. I did that. And then it says do zoom fit. So zoom, and we go all the way down to 0, or simply do zoom and hit 0. And now we have this picture, and I'm going to draw this picture. Okay, here we go. It's here, it's here, and it's back up there. And that's it. Okay, I want honest feedback. This is how you're going to do it so that other people cannot see it. Let me come up here and stop this. Do me a favor right now, and